Good day to all of you. My name is Abdurrahman Azzeddin, and today we are going to discuss what are artificial neural networks and artificial intelligence. So, it's been a topic lately that most people are getting to know better, but I just thought to make a quick summary. And I first start by asking what are neural networks and what is artificial intelligence. But first, we need to know what is human intelligence. Human intelligence is the mental quality that consists of the abilities to learn from experience and make decisions, as well as adapting to new situations. Okay, as well as adapting to new situations. This is usually done in the human brain through the human brain cells. That is what's called neurons. Okay, if you look at neurons, neurons form a complex, highly interconnected network that sends electrical signals to each other to process information and make decisions. Okay, this is usually how we think. This is usually how we do things. But if you truly think about it, our brain functions like a black box, meaning it takes some input and then produces some output. But have you ever known how this happens? I mean, have you ever thought how this happens? Yes, it happens in our brain. But did you ever feel the process? Did you ever feel the process in your brain while you are listening or while you are talking? You usually don't, okay? Usually our brain functions sort of like a black box. Suppose I say the word boat, okay? If I say the word boat, this is the input to your brain, okay? And you simply draw a boat's image as the output in your brain, okay? But you never really knew how this happened, right? It just happened. It's like a black box. Your brain takes the word boat as an input and it just produces this boat's image or any other boat's image as the output through this black box process, okay? So you can truly think about it from another perspective that different humans, different experiences and learnings, or past experiences, I mean, leads to different brain architectures and neural connections. Okay, so in fact, as a matter of fact, different brain architectures will result in different results or result in different outputs through this black box. So we can think about it that every one of us has a different black box. Okay, so yeah, this is just a quick demonstration. This also can be said for artificial neural networks, and that's where we get what are artificial neural networks and what is deep learning and artificial intelligence. Artificial neural networks is just a way to mimic the human natural neural network, okay, but on a less complicated scale. They can perform specific tasks, but most recently there are new AIs such as ChatGPT, Gemini, and Claude, and many others, of course, that can perform multiple tasks or may be seen as sort of a general AI, you know. But usually they can find the patterns and perform tasks by learning from the data. Okay, that's all there is. And we'll talk later why it is on a less complicated scale. But actually, neural networks, don't be scared. Neural networks are all but mathematics, and this is just simple. It's just a simple view of how it may look. Okay, but actually, it acts in a way that it also receives some inputs and it produces some output. It's quite like the human brain. Okay, so there are inputs, and for each circle here, we consider each circle as a neuron. Okay, and these lines are the neural connections. Okay, so you have an input and you have an output, and just like our brain, we know the input and we know the output, but we don't truly understand how the black box works in the middle. So these neural networks, these lines making these connections contain what is called weights. Okay, the weights are just numbers, but you can think of weights as the way a neural network takes the input and translates it through the network layers to outputs. Okay, they learn these weights from the data provided. Okay, from this is the neural network's experience and learning way. Okay, but neural networks, just like our brains, learn these weights in their own manner throughout some algorithms, like what's called backpropagation. But we really can't predict how it's going to be. It's just like raising two children in the same environment, but yet everyone learns something different, or everyone has their own mind. If I say the word boat, everyone might draw a different boat. Okay, so we can't really, nor even easily, trace how the neural network makes its decisions. Same can be said for children, at first at least. Okay, it just figures out its own patterns from the data. Okay, So after we said that the neural networks also acts like a black box, just like our brain, they learn from data through what's called forward and backward propagation. Just imagine something like student, where you ask the student a question and he simply replies with an answer. If the answer is correct, they are happy. If they and become more certain. If the answer is not correct, they sort of do what's called backward propagation. Okay, they adjust their way of thinking. They adjust their weights. Okay, this is what's called neural network training. Okay, so but why can't we design neural networks that's more like the brain? Okay, it's truly because the human neurons are quite complex. Okay, if you look at the complicated brain neurons on the left, it's quite complicated compared to the simplified artificial neurons that we create. Yes, there are more complicated neural networks for those AI experts watching this, but this is just the simple basis of it. Okay, just a few numbers getting multiplied and added together. Okay, and according to some sources, the brain consists of over 100 trillion synaptic connections. There are more neurons in a single brain than stars in the Milky Way. So just imagine the number of neurons in your brain. Okay, but current AI models have a lot of neurons and connections. And actually, I believe most recently there exists a supercomputer that can perform a quintillion operations per second, which is a huge number. Okay, it would take us a lot of years if all of the humans performed one operation in a second. It might take us about 4 years to match that one quintillion operation. Okay, and I'm going to link that video in the description for everyone to watch. But in case you're interested, but still the AI models are not as sophisticated as a human brain. But on the other hand, the computer doesn't get tired, but that's why initially many AI model architectures were created to solve different problems, such as the fully connected neural networks, ANNs, or artificial neural networks, or what some call dense neural networks. They are usually good for handling numerical data, such as, let's say, you have some numerical data of a patient. You can train neural networks to know if the patient is ill or not, or have a specific disease. A convolutional neural network, CNN, good for handling image cases. These are working very well in many image processing tasks, such as detecting car plates, detecting people, or classifying. Say I give the AI model a photo of an X-ray of a patient. It tells me whether they have a disease or not. There exists another image model called the vision transformers. They are good for handling more difficult image data, or when the data is quite a lot. They usually uh, peak when there is a lot of data. And then the transformers, and you'll be surprised knowing that ChatGPT actually stands for Chat Generative Pre-trained Transformer. Okay, so it's actually good for handling text data. And even there exist several different architectures for the same type of neural network. Like for the convolutional neural network, there exists the DenseNet, ResNet, and AlexNet. These are all trying to solve different problems within the same type of neural network. Okay, but why is it called deep learning? If you think about it, they meant deep learning because the more hidden layers, or the more hidden neural connection, like in our brain, you just know the input and output, but the more neural connections you have, the deeper you can think about the problem. Okay, so does this mean that few hidden layers mean not very good results, and we can simply say that more hidden layers equals a bigger black box means deeper thinking means better results? Not really. Okay, it's not always good. Imagine just you're trying to use a complex neural network, or you simply get someone like Einstein, and you just keep training them to add two numbers, x plus y equals x plus y, or 2 plus 2 equals 4. Okay, so it doesn't really make sense. You can just imagine using a very complex AI model or a very big black box for simple tasks is just like using a bulldozer to hammer a nail. It's not that efficient, and it might not get it right. Okay, that's just one big waste of resources, and it may also get it incorrectly. Imagine you are trying to be that accurate with that complex or big tool you're having. It's like using all your brain power to add two numbers. Instead of just adding them, you make up complex equations to add those two numbers. It's not very efficient. Okay. Lastly, there are some popular frameworks for working with neural networks, such as it's usually or mainly used in Python programming languages. There exists many other languages, but most recently, that's the most frequent and well-known programming language. And two of the most well-known frameworks for um, AI development is TensorFlow and Keras as well as PyTorch. These two work in Python. Here you will find I have listed a quick like Kaggle notebook and GitHub notebook. That's just for everyone to watch. Here is your first artificial neural network with TensorFlow for regression problem and classification problem. Those are two different types of problems. You will find I have listed how the neural network trains. It's just full of comments for everyone to watch, as well as some visualization for the regression and the output for the code. The same can be said for classification. Here are the same example. And this is the GitHub for your first artificial neural network with TensorFlow for regression as well as classification. You will find that the code is actually listed in here as well. The same code that's on Kaggle, but just for everyone to easily download from another source. The same was done with PyTorch so that everyone can check the code. This is almost the same problems, but with PyTorch for classification and regression. The same is here, just on GitHub for anyone to download. These links will be provided in the description. Feel free to leave a comment or ask about anything that would be for me to create a specific video for you or even discuss a topic that would be fine with me. Feel free to follow me on any of those social medias or contact with me. I try to post some elegant solutions, especially on Liquid that I'm just getting started back on once again. You can follow my most recent research throughout my Google Scholar or my ResearchGate accounts. And I have added some extra resources to visualize and to study. Something like TensorFlow Playground, that's just good for visualizing how neural networks actually work. I find it very fun to work around with this, have a lot of problems and different visualizations so you can try it out. And also the references to this presentation. Thank you for watching. I hope you've had fun, and I'll see you in the next one.